Now let's try the left side. So I've got 1 minus 2 cosine squared. Now that'd be really slick if that was a sine up there, because we could replace it with a double angle or something like that. But it's not. So what I'm going to do here is I am going to replace this cosine squared with something that I already know. So I know that cosine squared of an angle plus the sine squared of an angle is equal to 1, which means that cosine squared of an angle is equal to 1 minus sine squared of an angle. Okay, so we'll keep that thought here, and we'll use that as the insert here on this side. So this is going to be 1 minus 2 times this mess, so 1 minus sine squared theta, and that's over, I used theta and I was supposed to use gamma. We'll stay consistent here. So sine gamma, cosine gamma. Now I'm going to distribute my 2 in. So that's going to be 1 minus 2 plus 2 sine squared gamma over sine gamma times cosine gamma. So did that actually get me anywhere? I'm not so certain it did. Now let's keep trying to play around with this thing and see what we get. So let me pause it and think for a minute. I just don't like that approach, so I'm gonna scratch it off and try something else. Let's do the following. See, it'd be nice if this guy wasn't there, because then this thing would easily factor. Maybe let's try the right side. Okay. So I'll rewrite these in terms of sine and cosine. So that's going to be so the tangent of gamma minus the cotangent of gamma should be equal to sine gamma over cosine gamma minus cosine gamma over sine gamma. Get a common denominator. That gives me sine squared gamma minus cosine squared gamma over sine gamma cosine gamma. Now, this seems really close because my denominator's matching up, although that doesn't look like a gamma. Let's fix it. That's good enough. So I need to make this guy look like this guy up here. So since this guy only has cosines, what I'm going to do, I think I see where I went wrong before. So I'm going to switch this guy. So sine squared gamma, actually let me write that in different colors so it's not confusing. So sine squared gamma should be equal to 1 minus cosine squared gamma. So let's insert that into here. So it'll be 1 minus cosine squared gamma minus, there it is, cosine squared gamma all over sine gamma times cosine gamma. And now I got 2 of these bad boys right here. And so that's going to be 1 minus 2 cosine squared gamma over sine gamma cosine gamma. So that's our proof. So if you look back at what I started at the beginning, if you want to stop right now and you got it, great. But look, the problem that I made in the beginning here is what I should have done is instead of working with this guy right here, I should have worked with this guy. And I should have said that since sine squared gamma plus cosine squared gamma is equal to 1, I should have stuck this guy right here. And so I should have started with sine squared gamma. So this is a separate thought. So sine squared gamma plus cosine squared gamma minus 2 cosine squared gamma over that sine gamma, cosine gamma. Now, what you have happen is this guy right here cancels with one of these, and so we're going to get sine squared gamma minus cosine squared gamma over sine gamma, cosine gamma. And then what you would do is you would split each of these guys up, which is essentially the opposite of what I did above, and you get the same answer. Now, would you necessarily see that and be like, oh, I see a 1, I'm going to insert sine squared and cosine squared? Probably not. Okay, so sometimes it does take playing around with the other side to maybe get your solution. Okay, but that's the idea, is you just keep playing around with them and see what happens.